So today we're going to be hearing about the South Atlantic Blueprint Simple Viewer, which has recently undergone a redesign. And speaking to us today are going to be Amy Keister, the GIS coordinator for the South Atlantic Blueprint, and Brendan Ward, who is a software development team lead with the Conservation Biology Institute.
So we've been really fortunate to get to work with Brendan over many years to first create the Simple Viewer and then redesign and add new things to it as we go. And we really think he has outdone himself this time. We're very excited to show you some of the new features that he's incorporated. Before we get started, I wanted to just kind of set the mood and remind everybody what we're talking about. The Simple Viewer is a way to access the South Atlantic Conservation Blueprint, and that blueprint is a living spatial plan that prioritizes opportunities for shared conservation action in the face of future change. And you can see the geography that the South Atlantic Blueprint covers here in this map. But do not despair. If you fall in an area outside of this geography, the South Atlantic Blueprint feeds into the Southeast Blueprint, which covers the entire Southeast, and it even covers the Northeast as well. So no matter where you are, we're going to have a conservation prioritization that we can help you use. This Simple Viewer right now is focused on the South Atlantic region. And I also wanted to remind you guys that when we say that it's a living spatial plan, we are not kidding. We continue to update and revise this blueprint, and we're currently on blueprint version 2.2, and it gets better every revision based on feedback from people who actually use it on the ground. I also want to remind you guys that the Blueprint 2.2 is completely data-driven. So it's created, the foundation data sets are our indicators, and our indicators represent either ecosystem integrity or the integrity of cultural resources. And we prioritize the landscape using those indicators. We calculate ecosystem integrity and ecosystem priority using an optimization software called Zonation. We do a connectivity analysis using Linkage Mapper. And all of that feeds in to create the overall priority scores that you saw in the map on the previous slide. So we have a lot of underlying data that we need to communicate to our users. And that is one of the big motivations for creating the Simple Viewer, is we don't just want our users to see the final priority. We want them to be able to dig under the hood and see why an area is a priority. I also wanted to point out that, as we said, this is a living spatial plan, and it gets revised based on feedback and work from people who actually use it on the ground. So Hillary keeps track of our involvement numbers, and so far we have nearly 600 people from 165 organizations who've been directly involved in creating and improving the blueprint in our different versions. And I also wanted to remind us that the entire purpose of the blueprint is to help us impact and target conservation on the ground. And so we do a lot of user support for the blueprint. Louise and Hillary are here to do user support. And so far, more than 100 people from over 50 different organizations have used the blueprint. And so we have targeted a pretty good chunk of money to conservation on the ground using these spatial priorities. So we just wanted to keep that in mind as we talk about the Simple Viewer. So the Simple Viewer is one way that our users can access the blueprint data and the underlying data. We have two main routes that people can use to get to this data. The first one is the Conservation Planning Atlas at salcc.databasin.org. And we consider this kind of a GIS-light application. This is a place where you can go to see the blueprint layer, all of the indicator layers. You can overlay those. You can bring them into a mapping platform. You can overlay them. You can overlay them with thousands of other layers that other conservation people have added to this platform. On this platform, you can also read the metadata and download the data for use on your own computer. So it's a very important way that we communicate the blueprint data to our users. But we found it wasn't doing everything that we needed for our users, and that was why we created the Simple Viewer. And the Simple Viewer is a custom application dedicated entirely to the blueprint. And we've done some summaries in advance that help you see the blueprint and the underlying data for the blueprint. And so that's what we're going to check out right now. So I'm going to switch out of this, and we're going to go to a live demonstration of the Simple Viewer. So I first accessed the Simple Viewer at blueprint.southatlanticlcc.org. I'll notice that first thing I see is a map of the blueprint, and I have a sidebar that I can use to learn about the blueprint. I can read about the priority classes and how they're created and defined. I also have some tips on how to use this viewer and the credits for the viewer. I want to mention in this new version of the Simple Viewer, there are two different modes for how I can interact with the blueprint and the underlying data. We're going to cover, the mode we're going to cover first is the one that you might be familiar with if you've used the Simple Viewer in the past. And in that mode, you can zoom in and select either subwatersheds or marine leaf blocks, depending on where you are in the blueprint. And you can see summaries of the blueprint and indicator data based on these either subwatersheds or marine leaf blocks. So I've zoomed in here into a coastal area in Georgia. I'm just a little bit north of the Altamaha River, and I'm going to select the subwatershed. Once I select that, I notice that my side panel has changed. And now I can see that I've selected the Jericho River, Laurel View River subwatershed. It's about 120,000 acres. And it's got some really high priority stuff going on in here. I've got 10% of this subwatershed that's in the highest priority class, and then an additional 41% that's considered high priority. We've got another 41% that's medium priority. We've got some corridors in there. So only 6% of this subwatershed is not some type of priority for shared conservation action. So I know based on the blueprint, there's some really good stuff in this subwatershed, and it'd be a good place for me to work. And if I want to work here, I might want to check out the regional and statewide conservation plans that overlap this area. So we've provided some links to those here. We've also retained the workshop feedback we got back in Blueprint 1.0, back in 2013. And this is where some experts have told us some important things about this watershed. But I want to know why this is such a high priority. What's going on in the subwatershed that makes me want to work there? So I'm going to click on the Indicators tab. Now, the first thing I notice when I click on the Indicators tab is that I see my broad ecosystem types. So I can see that forested wetland covers about 43% of the area in this subwatershed. And I have 3 forested wetland indicators that help measure ecosystem integrity and drive the priorities for this ecosystem. I also have pine and prairie ecosystem in this area, estuarine ecosystem. We've got maritime forest and freshwater marsh. So we have a lot of ecosystems that occur in this subwatershed, and we have indicators for each broad ecosystem type. We also have our cross-ecosystem groups of indicators, and those are our freshwater aquatic, our landscapes, and our waterscapes. So we've got a lot of indicators that are influencing the priorities, the blueprint priorities in this subwatershed. The other thing I notice when I first click on the Indicators tab is I have these bar charts underneath each indicator. They range from low to high, and I can see the average value for the indicator inside this subwatershed. So just as a really quick glance, I can see that forested wetlands is closer to the high, pine and prairie amphibians, wetland patch size in my estuarine system, maritime forest, permeable surface, riparian buffers, maybe my low urban historic landscapes. These are indicators that are ranging towards that high side, and those are probably the indicators that are making these high priority pixels. But that's not really a lot of information. That's just kind of a first impression. And I want to find out more about each of these indicators and how they're scoring inside this subwatershed. So I clicked on forested wetland amphibians, and now I can learn more about this forested wetland amphibian indicator. I can find out that it draws from the priority amphibian and reptile conservation areas, which we call PARCAs for short. And those PARCAs are expert-driven designations that capture places capable of supporting viable amphibian and reptile populations. I also can see that there are 2 possible values that I get in this indicator in the forested wetland amphibian indicator in the subwatershed. It's either inside a parka, which means it's got a high value, or it's outside of a parka, which means it's got a low value for this indicator. And so 79% of the forested wetland pixels in the subwatershed are considered inside of a parka, so they have a high value for this indicator. Now I'm going to go back, and I want to learn more about forested wetland birds. So when I click on that indicator, every time I do that, I can learn a little bit about what the indicator is representing. I can find out that forested wetland birds is an index of habitat suitability for 6 bird species. It's based on patch size and proximity to water. Now, in this indicator, in my previous indicator, I just had 2 possible values. In this one, I have 4 possible values. So my lowest possible value, which would be a pixel that we don't consider in good condition at this time, is a pixel that is not identified as suitable habitat for any of our 6 forested wetland bird species. The next step up from that is a pixel that we would consider in good condition, and it's been identified as suitable habitat for the northern parula, the black-throated green warbler, the red-headed woodpecker, or the chuckwill's widow. So that's in good condition, but it could be in even better condition if it was also suitable for the prothonotary warbler. And then the very best condition class would be suitable for all 6 of our forested wetland bird species, including the Swainson's warbler. So overall, 78% of the forested wetland pixels inside this subwatershed are considered in some type of good condition. The very, very best pixels, there's only 3.5% of those in that very top condition class. This might not be enough information for you, even at this level. In order to get more information, we provide a link that takes you outside of the simple viewer. It goes back to the Conservation Planning Atlas. And here, I can see how this indicator was created. I have links to all of the data that we have that was used for this indicator. And I can really dig into the details and find out more about the indicator. But I'm going to stick in the simple viewer for right now. So those are our indicators, and you can go through each indicator and learn more about them in that way. I'm going to move on to the Threats tab. So you can access all the indicator data like we've shown. We've also summarized 2 major threats that might impact the future condition of these indicators in this version of the simple viewer. The first one is sea level rise. So we have this graph here showing you the potential impacts of sea level rise in the subwatershed. Currently, with 0 feet of sea level rise, about 24% of this subwatershed is likely to be impacted by inundation at the average highest tide. And so this is information that was developed by NOAA that we have summarized for this viewer. And you can see how the percent of the subwatershed that is likely to be impacted by the inundation at the average high tide changes with sea level rise. You can see there's a jump when sea level rise gets to 1 foot, where about 30% of this subwatershed is likely to be impacted. Then it gradually increases up to 5 foot of sea level rise, where we have about 32% of the subwatershed impacted. And then there's another bigger jump at 6 foot, getting up to about 38% of this subwatershed likely to be impacted by inundation at the average high tide. If you're interested in sea level rise, I would really encourage you to go to the NOAA website. So we've provided you a link to the place where we got the data for this chart, and then you can also check out the sea level rise viewer, which unfortunately is down today. But if you go there, you can learn more about the mapping confidence that they have for these values. But this gives you a quick introduction into the sea level rise, potential sea level rise impacts in this subwatershed. We have a very similar chart here for urban growth. This is based on our sleuth data, and we can see that in 2020, we're predicted to have about 6% of the subwatershed impacted by urban growth. You can see how that changes over time, ending in 2100 with 15%. So this helps you put your conservation actions in context. It doesn't mean you're not supposed to work in these areas because there are threats, but you might think about these threats as you plan your conservation actions in this subwatershed. And then finally, we can go to the Partners tab. And in the Partners tab, we can find out how much of this subwatershed is already in some type of conservation protection, who owns that, what type of ownership that is it federal or state, private. You can find out the status there. And you can also find out the land trusts that are active in this subwatershed you might want to partner with. So this is the updated version of this type of interaction with the simple viewer where you select and see summarized data by either subwatersheds or marine lease blocks. So if I'm working in this subwatershed and I've reviewed all this information in the simple viewer, I might want to be able to have these charts and graphs and the summarized information to make my own documents or presentations. If I'm in that position, I can now download a report. When I hit the download report, it downloads a Word document to my machine that I can then open up, and I see all the same information that I saw navigating around the simple viewer in a report format. We actually have a little more room to work in here, so we can add a little bit more information. But I have all the information about the blueprint. I have the map of the blueprint priorities, priority categories. I have all the charts and tables. And in these tables, not only do I have the percent of the subwatershed that fall into each of these priority categories, I have the acres as well. I can see how much is in each ecosystem. I can see all of the values for the individual indicators. All of the data that you saw is now available in this report form. This is a new feature that we developed for this version of the Simple Viewer, and we're really excited to get your feedback to see what kind of value or utility you find in this report, and if this helps clear up some of the barriers that you have to accessing this data and using it in your daily work. So that's a very exciting new feature that we have. I also want to go back now to the Simple Viewer we were looking at and remind you that we have two different modes. And I want to switch now to what we internally in the office call the Pixel Hunter mode. So I'm going to click on this button in this side over here. When I hover over it, it says View Pixel Level Details. When I click on that, I switch to the Pixel Hunter mode. And now, instead of having to see the data summarized by a subwatershed, I can find out the values for the blueprint and the indicators specifically underneath each pixel. So I notice that now that I've switched over, I see a bullseye appear in the middle of my map. I see that my cursor has turned into a hand. I can click and use that hand to pan around the map. And as I do, I can find out the values for the blueprint and all of the indicators that apply to that pixel in my side panel. And so remember how I said earlier that we knew that there was some important stuff in this subwatershed for forested wetland amphibians, and we knew there was some important stuff for birds. We didn't know exactly where it was. We just knew that 70-some% of the forested wetland area in there was a high priority for forested wetland amphibians. Well, now I can find out exactly which pixel is a high priority for forested wetland amphibians. And if I'm interested in a particular indicator, I can click on that indicator. I'm actually going to go to, what would I want to see? Let's go to maybe resilient biodiversity hotspots, just because it has a larger range of potential values. So I can scroll along and see how those values change. And look how fast this is. Brenda's going to talk about why this is so fast. But I can see if I'm looking for the reason why this pixel might be high, it could be because it's got a high score for resilient biodiversity hotspots. It's good for forested wetland amphibians and birds, extent, permeable surface. Now I know exactly why the blueprint is scoring the way it is based on those underlying indicators. So we're very excited for you all to explore this and see if it fills a gap that you had in previous versions of the Simple Viewer, where you could find out generally for a subwatershed why things are important. Now I can find out exactly why this particular pixel is important. So we're super excited about that new development. And then really quickly, before I pass it off to Brendan, I wanted to show you another amazing improvement in the Simple Viewer this year, and that is that it is mobile friendly. So no matter what device you're on, you're going to be able to access information from the Simple Viewer. So here I'm showing you an example of how this might look in the iPhone 5. So in your iPhone 5, you open up your web browser, you navigate to blueprint.southatlanticlcc.org, and you can see the Simple Viewer. The interactions are a little bit different because we have a smaller screen and we can use our fingers to move the map around, and we can pinch in and out to zoom in and out. But you'll see a lot of the same stuff. You can zoom in, you can select your watershed, and then you can find out the blueprint priorities. You can find out about each of the indicators based on their ecosystem. You still have the same amount of detailed data for those indicators that you had in your desktop version. You've got your threat data and your partner data as well. So we see a lot of utility for us as staff when we're traveling around and we want to show somebody this cool viewer. We don't have to pull out our whole laptop. We can sit at dinner and show them this on the phone. And we're excited to hear how this impacts your use of the Simple Viewer as well. So I wanted to really quickly show you this live demo so that we can pass it over to Brendan, and he can talk about how he actually did this stuff, the magical things in the background that makes these things so fast.
So thank you to the South Atlantic team for inviting me to co-present on this webinar. I'm delighted to be here, albeit a little early in our time zone. Before I spring into the technical side of it, I want to mention briefly a little bit more the human aspect of this. And in working with the South Atlantic team on this through several iterations, I want to highlight that it feels like there was really two key elements of this being a successful venture together. One is my observation that the South Atlantic team, the entire team there at South Atlantic, has been highly engaged with this project throughout its development. It wasn't just a hand it off to us and let us do our work, our magical work in the black box and hand it back. It was high levels of engagement back and forth all the way through. So Amy was giving me far too much credit at the beginning of her talk about what we had done here. This was a joint and highly collaborative effort, so many thanks to the South Atlantic team for participating with us on that. The other is that the South Atlantic team is very highly engaged with their stakeholders and with all of you that are on the call here, and I think that that's been key to having a solid understanding of real-world, real user needs that we could use to drive the technical development, rather than wish lists or perceived needs. And so we hope that the outcome of that is that this new version and each version that we hope will follow really meets real needs so that you can more easily take conservation actions on the landscape and not just got caught up with a lot of the barriers on the technical side of things. Okay, so with that, I'm going to spring into what I would call the behind-the-scenes version of the Simple Viewer, where we take what Amy was just calling magic, and we make it a whole lot less magical when we show you a little bit about how we did it. I'm going to talk about two main parts here. I'm going to start with talking through the mobile design briefly, and then spring into a little bit more discussion around the Pixel Hunter. And then at the end of all of this, we have a Q&A opportunity for any of you on the call here to ask us questions. On the mobile design side of things, this was a very new aspect of the Simple Viewer that came out of our most recent work. The goals were really to preserve as much of the rich functionality of the desktop version, but make it easily accessible on very small devices. So like Amy was saying moments ago, it's a lot easier to engage with key folks around the blueprint and share a key aspect of it in kind of a real-time meeting. You don't have to pull out your laptop and get on the local Wi-Fi, et cetera. It's right there and easily accessible. We also, in moving it to a mobile platform, really wanted to adapt certain aspects of the layout and interaction to best fit on mobile devices. The way that you would interact with an application on a mobile device is quite different than the way that you would interact with it on a desktop browser, not just because of the change in the size of the screen that you're looking at. And so this brought with it some unique constraints. On the mobile device side, there's many different makes of mobile devices as well as many different sizes. And we needed something that was fairly simple and easy to develop and push out new versions. And we also needed to have it nicely adapt between the smallest phones to medium-sized tablets and so on. We also know, based on other experience from doing other applications and from seeing sort of the application development world over the last several years, that building native mobile applications is expensive. And it's also hard to keep them feeling very unified with your overall vision for the application. I'm not ruling out a native application for the blueprint in the future. There may be a perfect fit for it, but what we're doing right now in terms of this mobile responsive design gives us a way to validate and really identify what are the key aspects of the blueprint that people are engaging with on their mobile devices. And that'll help us target better the effort toward achieving those in terms of a native application. Another interesting constraint that presented here was that the touch interactions in terms of clicking or tapping on things is different when you're using a touchscreen device, especially one that you're holding in the palm of your hand, versus what you're doing on a desktop computer and using your mouse and your cursor. And because of that, the way that you expect to interact with an application is different. One of the particularly challenging things for us here with the mobile version is just the sheer amount of information that we're trying to communicate. So to give you a glimpse back into the past a little bit, this is the Blueprint Simple Viewer as of version 2.1. And as you can see, there's a lot of information going on. We've got a mapping interface where we need to show you the pixels of the blueprint priorities, highlight your sub-watershed or your marine lease block unit, as well as rich information in the sidebar, helping you understand the breakdown of the ecosystems, the scoring of each of the indicators within those, and further explanation of each of those indicators to help you get your head around what they actually mean and what high versus low means. So this presented some immediate challenges when we then tried to squish this thing into a couple inches by a couple inches in terms of the screen, and also not relying on hover-type interactions as you hover your mouse cursor over things to highlight them. That was no longer an option for us in a device where you can't hover over things. So after going through a lot of paper prototyping, we landed on what we would call a responsive design, where key aspects of the layout change or adapt based on the size of the screen that the application detects that it's running on. So it's the same overall code base, which keeps things very simple for us from a maintenance and improvement standpoint. There's just one code base we need to touch when we want to add in new versions of the blueprint data, updated information on threats, and so on. But we're still able to target all of these different mobile devices and screen sizes. The application is also able to detect if it's running on a mobile device, and if it does, then it will switch over to using mobile-oriented functionality. And so as Amy was just demonstrating there, it's not just that the footprint of the screen changed, it's that when we detect we're on mobile, we bring in, say, tabs along the bottom so that you can switch between a map view or searching for a location or viewing details for a selected area. What was interesting about this is as we were working our way through the mobile version, it ended up driving a lot of redesign and thinking hard about the overall design of the desktop-based application as well. Number one, we wanted to keep them feeling very much in the family with each other and not let them diverge too much. And number two, we discovered a few things about how to simplify information presentation, we hope, to make it easier to engage with the blueprint in the first place and still derive a lot of meaning without having a whole lot of visual clutter in your way on the screen. We learned a few things along the way of doing this. I would say the key among those is that we just really had to focus on simplifying, figuring out every possible aspect of this that we could simplify a little bit. Is there text that we no longer need to show? Is there information that we could present in a slightly different structure to still help you really understand the context and meaning of what you're looking at, but not have it all getting in your way of working your way through the data? That drove some hard decisions about what needed to be visible at a single point in time when you're interacting with it. And sometimes you have to let things go. One of the things that we struggled with during development of this is our fixation on this as a map-oriented application. We really wanted to have the map visible most of the time, kind of like you would get within a map-based application like Google Maps or Apple Maps or other map-based navigation apps. And we discovered that that was really causing some poor design decisions and making it harder to actually understand what you were looking at in an effective way. And so we had to pivot a little bit and realize, okay, there are certain cases where it's really helpful to look at the map, and there are certain cases where we just need to take over that whole screen that you have available and show you information about an area instead. We also did a lot of experimentation and iteration. So this is not one of those propositions where you come up with a grand idea and you immediately launch it and it just works. It takes a lot of iterating, and we're very appreciative that the team at South Atlantic was able to engage with us, give us feedback, test on sample real users, and help us continue to tune and identify those things that still were awkward for folks and things that we could really address by doing another round of development. So with that, I want to switch into talking about the Pixel Hunter, as we're calling it now. Our goals here were really around dealing with how information is aggregated. So as Amy was just talking us through, sometimes showing a summary for a larger area like a subwatershed or a marine leaf block is helpful when you're looking at it at the landscape scale, but oftentimes you really want to know what's going on at a particular spot. And sometimes to understand the why of the blueprint, you really need to drill down at that specific location. Another constraint or goal that we brought to this is we wanted this to feel fast. We've worked with a lot of other browser-based GIS applications, and the typical mode of interacting is that you click on an area on the screen and you wait a while, sometimes a few seconds, sometimes 30 seconds, sometimes a lot longer for legacy applications, and then you'll get an ugly little table display that tries to communicate the values of that particular place. We didn't feel that was going to be adequate for what we were trying to accomplish here. We wanted it to feel very responsive because we wanted you to feel like a data explorer. We wanted you to really be uncovering the why of the blueprint in real time. We also had a couple technical constraints on this. In terms of approaching the simple viewer from a technical perspective, we're also trying to keep it very simple. That keeps costs down, and it improves our agility for making improvements and accommodating new data. So wherever possible, we were trying to avoid complexity on the back end. We didn't want any complex servers. We didn't want any servers that required yearly hefty subscription prices and so on. So we were trying to keep it simple. But in the face of that, we're also trying to accommodate 27 indicators worth of raster data, which is a lot of information for us to try and present in an interactive and real-time fashion in the way that we were going for. As we did further research into this, we found that a lot of the real-time interaction in maps in your browser is using points, lines, and polygons. And there's different ways of shipping those up to your browser so that as you hover your mouse cursor over those, you immediately can reveal the data that those contain. We didn't really find anything that did that for raster data. And so we realized we needed to develop our own approach. So we explored this idea a little bit. At a fundamental level, for delivering the Blueprint Simple Viewer and many other web-based GIS platforms that use maps, we're using what we would call map tiles. So in this case, like I've got here in the bottom right, it's basically a picture of a map, a picture of your data that you would sort of geolocate. You would display it over a particular part of the world. In terms of the technical backend, it's just a tile. It's a picture containing pixel values. And so we thought about this for a little bit. We know how to make pictures of our data. Is there a way that we could use the picture to encompass more of the actual underlying values of our data and get those back when we work with it out in your browser, rather than just showing you a picture of it? And so we came up with this idea of using an encoding approach for taking the values of each of the indicators and stacking them up, and using image and tile technology for actually working with those out in your browser. So I'm going to try and walk you through a simple, ultra-simplified example here that we're calling data tiles. Please don't get hung up on the specific pictures of any of these birds. These are representative rather than actual for your particular region. So let's say for a particular pixel on the ground, we have three different indicators that we're working with. We have one that measures the condition of wetland birds, one that measures riparian buffers, and one that measures the pine and prairie amphibians. And so for the birds, let's say that it has a value of 2, which means in this case, for this indicator, it was the highest value, and it indicated that there was potential presence for a particular warbler species that's very picky about its habitat. For the riparian buffers, this also was in its highest category because it had more than 95% cover in natural vegetation within those buffers. And for the pine and prairie amphibians, this fell within a priority conservation area. And so what we can do with those individual values of 2 and 5 and 1 is we can just use a little bit of simple math to put them together into a new number. So let's say that we multiply the wetland birds by 100. So that takes our hundreds place. We multiply the riparian buffers by 10, and so that takes our tens place. And we don't multiply the pine and prairie amphibians by anything. And so this lets us take 3 indicators and make a new number out of them. That's 251. Now I know what y'all are thinking at this point. Geez, give me a break. Too much math. So bear with me for just a moment as I work through this. So once we have our number of combining these different indicators, we can assign this a color value. So let's call this one bright blue. We can repeat this approach for every other pixel within the map, and now we have a picture. You can't really look at the picture and immediately derive meaning out of it as a person. The picture doesn't communicate, but to a computer, the underlying values are there. And so from the color, we can turn that back into a number, and because we know how we put all of these different indicators together, we can unpack back to the original values entirely within your browser. One of the nice things there's 2 nice things about using images and tiles in this approach. One is that we can leverage image compression techniques. These are things that have been polished over several decades now in terms of improving the ability to really squish down picture information for use on the internet. The other is because pictures make such a large part of the internet, browsers know how to work with those data. So here we didn't have to invent a new technology stack for encoding and encapsulating raster data and shipping that up to your browser and writing a bunch of custom technology in your browser to decode those. We can just ship images around, and your browser already knows how to work with those images and give us back data. So in short, we basically do an encoding of the indicator data across all 27 indicators, plus the blueprint and the ecosystems layer. Do that all in advance, and we make a bunch of tiles. We can stick all of those tiles out on a very lightweight server that costs us very little, has very low complexity, and we're just serving map tiles at that point, so it's a very low complexity proposition. Once those map tiles make it to your browser, we reverse our math, and we get back the original pixel values. And that's what we can use to drive the sidebar and make it responsive in real time, as Amy was just demonstrating. And so this approach allowed us to keep it very fast and very lightweight, both from a user perspective as well as from a technical perspective. All of the underlying technology behind this is open source. And if you have further technical questions about any of those, I'd be happy to take a few of those now, or please let's follow up afterward. Super excited about what's going on in this space, and I think there's a lot more potential with what we can do with it. So in closing, thanks again to the South Atlantic team for inviting me to participate today. I really appreciate the opportunity to be here, and thanks to everyone listening in now or in the future for your interest in this topic and the great work that I think we're collectively doing around the Simple Viewer.